Okay, so let us start with the second module of mathematics. Okay, so basically the first thing you have mathematical induction and recursive relation. Let me just look at the syllabus. So you have mathematical induction, the well ordering principle, recursive definition, fundamental principles of counting, rules of sum product, permutation, combination, binomial theory, and combinations with repeations. Okay, no problem. We will do everything. Okay, we will just solve everything one by one. This might take a while or time. Okay, all set. Let us start. So mathematical induction. Okay, the method of mathematical. Okay, so let me just read out some basic theory part. The method of mathematical induction is based on a principle called induction principle. So what is mathematical induction principle? I am just saying this because we can't predict the UVTO board. Suddenly they might just ask us. So the principle is based on another principle known as well ordering principle. So you saw in that syllabus copy too much big dash. Don't get panic. That too much is nothing but only one thing. Okay. So what is this well order principle? Every non-empty non-empty subset of positive all z plus positive integers contains a small or at least element. Okay, or the set of all positive integers is well ordered. Okay. So and then induction principle. What is induction principle? This is the main thing, okay, which we will be using in our mathematical induction. The principle of mathematical induction is nothing but induction principle. So we say that let S of n denote an open statement. Whatever the given is there, right? In your question they gave, you just have to let that this thing be this. Okay. And then we say that denote an open statement that involves a positive integer n. Okay, suppose that the following consider holds. Okay, then first what we do, we took the given s of n, then what we will do, we will find s of 1. If it is true, then we go for this first step, and then we will go for a second step, that is s of k, induction step. This is the basic step and this is the induction step. Let me just write it, a basic step, induction step. Okay. Then we say where this k belongs to this positive integers, all positive integers. Then what we say, if this is true, if we assume this as true, then s of k plus 1, we have to prove that s of k plus 1 is also true. Then we say that s of n is true for all positive integers z plus. This is a basic procedure which will be happening throughout the problem in under mathematical induction. Okay. I have washed my glove, so it will be, I have to adjust with this normal thing. Okay. So let us go with the first question. Okay, so let us directly start. We don't have to waste so much time. Then we have here, for all n greater than equal to 1. So it says that prove that 1 plus 2 plus 3 so on up to n is equals to 1 by 2 into n into n plus 1. Okay, or n into n plus 1 by 2, both are same. Okay, so I will be using my book and as well as this thing to solve, so that I can use this book as notes, right, material. Then first one. Okay, so now it is said, prove by mathematical induction that for all x for all n greater than equal to 1, okay, 1 plus 2 plus 3 plus so on up to n is equals to n into n plus 1 whole divided by 2. Okay, so now what I will say, given what I said, s of n is equals to 1 plus 2 plus 3. So, okay, let s of n be such that 1 plus 2 plus so on up to n is equals to n into n plus 1 by 2. Okay, Now what I will do, I will take S of 1 is equals to 1 is equals to n should be there, right. So basically from here this main thing will come, 1 is equals to 1 into 1 plus 1 divided by 2, which is equals to 1 into 2 by 2, which is equals to 1. So I got 1 is equals to 1. Understood, right. And then what I will do, so this was by basic step, then I will go for induction step. Okay. Now what I will do, so I will assume S of n is true or verified, both are same, true for n is equals to k, where k is greater than equal to 1. So what I am doing, see, you had n is greater than equal to 1, so what I am doing now, k is greater than equal to 1, instead of n I am taking k. So how it will be, we are assuming that S of k such that 1 plus 2 plus 3, just replace n with k, is equals to k into k plus 1 by 2. So basically what we have to prove, okay, let me just show here. So what I got here, S of k, right, I got S of k is equals to k is equals to k into k plus 1 divided by 2. Okay, I cannot just write k, so I have to write 1 plus 2 plus 3 so on up to k. Now what I have to do, basically I have to find, I will be adding, okay, I will just add here k plus 1 on both the side, okay. So if I k plus 1 so on, it should be equal to, if I just make it I just add plus, where is k, that make it as k plus 1 into k plus 1 plus 1, that is k plus 2 divided by 2. So this should be my final answer, okay. But I cannot just directly write like this, so I have to prove it in a different way. So here, instead of, I have to get this answer, I know that. So what I am doing, first what I will do, I will add k plus 1 on both the side, add k plus 1 on both the sides. So we will have 1 plus 2 plus 3 so on up to k plus 1, okay, is equals to k into k plus 1 divided by 2 plus k plus 1, okay. Now what I will do here, so simple, what I will do, I will take k plus 1 by 2 as common factor, k plus 1 I have here and here, but here divided by 2 is not there, okay. I will just simply take it as common, k plus 1 by 2 as common. So what is the remaining, here only k will be remaining plus, now see here, since I took this whole thing as common, so here this is gone, but I have here divided by 2, so here above 2 should be there, okay. How here only k plus 2 came, I will just explain you here, okay. So I had like 1 by 2 k into k plus 1, sorry, k into k plus 1 by 2, then plus k plus 1. So now I took k plus 1 by 2 common, so what should be remaining, k plus 2. How means, if I multiply this now inside, if I multiply now, what I will get, k into k plus 1 by 2 again plus 2 into k plus 1 by 2, so such that this 2 get cancelled, so I will be getting the original term. That's why I am writing 2 here above, okay. Instead of k plus 1, 2 will come, such that if I multiply this 2 and this 2 will get cancelled, so only k plus 1 will be remaining over here. Oh, was it not? Yeah, it was visible, right, sorry for that, okay. Then now I can say that this thing, this is the statement now, S of k plus 1, whatever we have obtained, it satisfies the statement S of k plus 1. Therefore, we can now simply conclude that thus S of k plus 1 is true whenever S of k is true for all k greater than 1. So, S of k plus 1 is true whenever S of k is true for all n greater than or equal to 1. Same way, by mathematical induction, S of n is true for all k greater than or equal to 1. Okay, n or k both are same. First I will write k, then I will write, okay, since I took S of k, then by mathematical induction S of n is true for all n greater than or equal to 1 by mathematical induction. Okay, this one problem we have solved. Okay, let us move on to another problem. I think I will be solving some 7 to 8 all the problems which are given in the textbook. Then same thing they have said, prove by mathematical induction. Okay, 1 square plus 3 square plus 5 square plus so on up to 2n minus 1 the whole square. Okay, why what is in this order? This is 1 square, 2 square, so their difference is 2, right? Okay, or else you can say all odd squares. So why they have given 2n minus 1 is because any number multiplied by 2 gives us even, like 5 2s are 10, 7 2s are 14, 9 2s are 18, 11 2s are 22, 13 2s are 26. So all are even. Since 2n is even, then if I subtract 1, it will always give me odd number. For example, 5 2s are 10, 10 minus 1 is 9, 9 2s are 18, 18 minus 1 is 9. You can take plus 1, but in the question there is minus 1 is equals to 1 by 3 times of k into 2k minus 1 into 2k plus 1. Okay, you can also write this whole term divided by 3. Now, okay, let me just first write here and then explain the what to say tricky part here. So now I have to assume this thing as S of n, same thing. Okay, I will just write like this, S of n is just one. Then what I will do, S of 1 I will take, which is equals to 2 into 1 minus 1 whole square should be equal to 1 into, okay, here sorry, actually should be 2 n, I took k here, n into 2n minus 1 into 2n plus 1. Okay, by mistake I took k, sorry for that. So 1 by 3 into 1 into 2 into 1 minus 1 into 2 into 1 plus 1, which will be equal to 2 minus 1 is 1 into 1 into 2 plus 1 is 3 divided by 3 1. So I got 1 is equals to 1. I have this is also 1, right? 2 into 1 is 2, 2 minus 1 is 1, so 1 square is equals to 1. So 1 is equals to 1, proved. S of 1 is true. Okay, this is the basic step. I always take S of 1. Then now what I'll go for S of k is, I'll assume. Okay, you have to write that theory part. Assume S of k is true for all 1 plus 2 plus 1 square plus 3 square plus 5 square, so on 2k minus 1 the whole square is equals to 1 by 3 into k into 2k minus 1 into 2k plus 1. Now remember, I got this question right. So at the end what I have to get is, so here is 2k, so 2k is what, S of k is equals to this, like 1 by 3 into k into 2k minus 1, 2k plus 1. So I have to get in such a way that k plus 1 should come, and I have to just add k plus 1 in this place. So 2k, 2 into k plus 1, this will be become 2k plus 2 minus 1, so this will become plus 1. Okay, and here I should get 1 by 3 into k plus 1 into same, so 2k, 2 into k plus 1, so 2k plus 2 again minus 1, so it will be 2k plus 2 and minus 1 is plus 1 into again 2k plus 2 and plus 1, 2k plus 3. So I have to get what to say finally. So here it was 2k minus 1, right? So it should be 2k plus 1. You know, right, how 2k plus, so here 2k minus 1 the whole square. Okay, here 2k plus 1 the whole square. How means 2 into k plus 1. K plus 1 was like this 2. If you multiply 2k plus 2, So plus 2 minus 1 gives us plus 1. Okay. So I got 2k plus 1 the whole square. So remember, your final answer should be like this. Okay. For that, how we will be solving this? Okay, I got. So I assume this is also true for this. So now what I will do? I will just add 2k plus 1 the whole square. Okay, when I take k, if I take k plus 1, okay, s of k plus 1 is equal, okay, so I will get 2k plus 1 the whole square, right. So I am adding and subtracting, so adding this on both the side. Okay, this, let me, don't write this. Okay, so I will add that. So here 2k minus 1 the whole square plus 2k plus 1 the whole square is equals to 1 by 3 into k into 2k minus 1 into 2k plus 1. Here I will add 2k plus 1 the whole square. Okay. So I have simply added 2k plus 1 the whole square. Now again same thing, I will take something common here. What I will take common? I will just take 2k plus 1. So I have 2k plus 1 here also, I have 2k plus 1 here also. Let me just write like that. So 2k plus 1 along with 1 by 3. Okay. So if I take 1 by 3 here, then obviously I have to multiply 3 here, right. So what will be the remaining? So I took this, if I use my pencil, so I have taken this part and this part and 1 time of this part. So remaining is k into 2k minus 1 plus 3 into 2k plus 1. How 3 into 2k plus 1 came is, here since it was square, so 2 times it is. So this can be written as 2k plus 1 again into 2k plus 1. So only one time I am taking this outside common, only one time, not both the times. If I don't do like that, for example I am just showing. So 2 times as square is, if you take one time, so only, for example, k square plus k is there. If you take k common, so here k square ka 1k, k plus 1 will be there. Why? Because k is 2 times. Like that, here 2k plus 1 the whole square of the, only one time it has taken, so still 2k plus 1 is remained. But I also took 1 by 3 as common, that's why I have to multiply 3 inside, such that when I multiply this inside, 2k plus 1 and 2k plus 1 will become 2k plus 1 the whole square, and this 3 will be cancelled because of this 3. Okay. Now what I will do, I will simply open this inside, I will just multiply. So k into 2k is 2k square minus k plus 3 to the 6k plus 1. Okay. So 2k square minus k plus 6k, this I can write as 2k square minus k plus 6k is plus 5k plus 1. So I have 1 by 3 into 2k plus 1 into 2k square plus 5k plus 1. Now I have to solve this. Okay. Remember this thing, I just have to erase this now. I will keep this final answer as it is. So what I have, 2k square plus 5k plus 3, right. Oh shit, why did I make it as 1? This should be 3 here. Sorry. Yeah, I know I made mistake. Will be like, oh, this 3 should come. See, I have done 3 here, 3. How I remember it's 3? Because this sum is in my mind itself. Now what I have to do, I have to do this common term, grouping term. I have to get that term. So what I'll do, to get that, first what you do, you have to multiply this 2 with 3. Just multiply 2 with 3, so it will become like 5k plus 6. So this thing you won't change, just you have to, in your mind, just multiply this with this. So 2 3s are 6. So by adding you should get 5, and by multiplying you have to get 6. So arams you can say it's nothing but 2 and 3. So what you will write, 2k square plus 2k plus 3k plus 3. Now take common. So what is common here? So here 2k is common. Okay. So k plus 1 plus, what is common here? 3 is common, k plus 1. So what I got, ultimately I will write here 2k plus 3 into k plus 1. I can write vice versa also, first k plus 1 and 2k plus. So let me just write it off. I will show here also. So I will write 2k square plus 2k plus 3k plus 3, then 2k k plus 1 plus 3 k plus 1. First I will write common terms k plus 1, 2k plus 3. Okay, same thing I will write now, 2k plus 1 array, okay, divided by 3 into k plus 1 into 2k plus 3. So if I arrange this, it is k plus 1, okay, 2k plus 1, 2k plus 3, 1 by 3 into, okay. Now see this and see this, same, right? This thing why I showed you general plan. So you just have to do k plus 1 wherever k was there in the actual given question. Here you just have to add, make that k as k plus 1 and write it as it is. So it will be like this. You have to do add or multiply in such a way that you have to get this thing at the end. So what I did, I added this term. Okay, see in this thing, here when I take k plus 1, so what I had here, it is only k. So if I make it as k plus 1 in terms of k plus 1, I will get only k plus 1. So I will add on both the side. I understand. So s of k I have, k is equals to something like that, right? So what I will do, if I take s of k plus 1, so that will become a k plus 1 here. Okay, so that's why I took add and added k plus 1 both the side. Here I have 2k minus 1 the whole square, and if I take in terms of k plus 1, 2 into k plus 1 minus 1 the whole square will be 2k plus 1 the whole square. That's why I added 2k plus 1 the whole square on both sides. This is one trick to understand while doing your while writing in exam. Okay, 2 questions done. Let me move on fast now for third question. So here same, prove a mathematical induction that 1 into 3 plus 2 into 4 plus 3 into 5 so on plus n into n plus 2. So this is the form, say 1 into 1 plus 2. So 1 into 1 plus 2 1 plus 2 is 3, 1 into 3, 2 into 2 plus 4 is 4, 2 into 4, like that so on, is equals to n into n plus 1 into 2n plus 7 whole divided by 6. So I have to prove this. Okay, so now how I will do this? First I have to say that given s of n is this, first basic step, s of 1 I will take 1 into 1 plus 2 is equals to 1 into 1 plus 1 into 2n, sorry here 2n, 2 into 1 plus 7 whole divided by 6. So 1 into 1 plus 2, 3 is equals to, I will write here 1 into 1 plus 1, 1 into 2 into 2 into 1 is 2, 2 plus 7 is 9 divided by 6. So 2 1s are 2 3s are, then 3 1s are 3 3s are, which is equals to 3. Okay, it is true. Sometimes they will give sub questions like this should be asked as one question, but they will ask as sub questions. Suppose maximum if they have asked, they will ask for two sub questions under one question. Like for example 1a, they will ask like this. Okay, if this comes fine, but sometimes if they ask 3, right, try to do this properly, because one among them will be wrong, you cannot prove and you will leave it as it is. Just saying, sharing my experience. Okay, now s of k, I will assume s of n is true for all. Okay, I forgot to write for all in the question n greater than equal to 1. So I will assume s of k is also true such that 1 into 3 plus 2 into 4 plus 3 into 5 so on, k into k plus 2 is equals to k into k plus 1 into 2k plus 7 whole divided by 6. Now again let me just write it in the form of s of k plus 1. If I take like that, how I will get? Okay, so here I should get k plus 1 into k plus 3. Why? Because see here, k into k plus 2, right? So k is written as k plus 1, then k is written as k plus 1, k plus 1, then plus 2, k plus 3. This should be equals to, I'll write down, k plus 1 into, k is written as k plus 1, k plus 1 can be written as k plus 3 into 2 into k plus 1. So 2k plus 2, 2 plus 7 is 9 whole divided by 6. Okay, at the end you have to get this answer. Okay, so let us start. You understood, right, what we have to get at the end. So step 1 over here, induction step, we are doing induction step. So here I will add and I have to add and subtract. So like I said, I got this, right? So I will add this on both the side. Okay, understood, right? Simply if I make this as k plus 1 in terms of k plus 1, whatever I am getting, I am just adding that on both the side. So here I will have k into k plus 2 plus k plus 1 into k plus 3 is equals to k into k plus 1 into 2k plus 7 whole divided by 6 plus, not multiplication, plus k plus 1 k plus 3. Okay, now what I will do, which is common in this and this thing, this is common, so I will take k plus 1 common but along with 6. So what is remaining, k into 2k plus 7 plus here k plus 3 is remaining, but another thing what I have to mention is 6 into k plus 3. Now what I will do, I will just multiply this. So 2k square plus 7k plus 6k plus 6 3s are 18, which is equals to 2k square plus 13 na 13k plus 18. Here I have to write k plus 1 by 6 whole into 2k square plus 13k plus 18. Okay, so now see here, I have 2k square plus 13k plus 18. Okay, so now what I said, first multiply this with this, so that become 18 to the 36 by adding 13 and by multiplying 36. So 9 and 4 are the terms which gives us the term. So write in such a way that 18 and 9 has a common thing, so just write like that, 2k square plus 4k plus 9k plus 18. So now I can, what I can take, 2k common, so what is remaining, only k plus 2, then plus 9 common, k plus 2. Okay, so from this I can do it like that, right? Okay, I will keep it here and then I will write. So I can write k plus 1 divided by 6 into, this I will simplify here, 2k square plus 4k plus 9k plus 18, which is equals to 2k k plus 2 plus 9 k plus 2. Then I can simply write here k plus 2 into 2k plus 9. Okay, now see here, 2k plus 2 plus 9. Here I wrote 3. Why did I write 3 there? Sorry for what to say, k plus 1. Oh shit, sorry, actually I had to do k plus 1 and here it was n into n plus 2, so n plus 1 into n plus 3. But in the right hand side I had k into k plus 1 into 2k plus 7, right? So k plus 1 I have to do k plus 1 plus 1 is k plus 2 itself. Sorry for that mistake. I don't know why. From next time I will do properly. Okay, now see here, this and this is same. We had to. Then I will write thus this statement in the form of s of k plus 1, which is true for all s of k, where k greater than equal to 1. Therefore, we can prove by mathematical from mathematical induction, it is proved that s of n is equal to that n into n plus this thing, same thing you have to write the theory part. Okay, So now I'll do another sum. Here I'll explain it properly. I won't do mistake. Okay. Then I have here we have prove a mathematical induction for every positive integer n for all n. Phi divides n power phi minus n. So phi divides n power phi minus n is nothing but n power phi minus n divided by phi is divided by phi, or n power phi minus n is equals to phi into some integer where m belongs to some positive integer z. Okay, remember this thing because we will be using that later. Now what I have got, s of, let s of n is equals to 5 divides n power phi minus n, then I will take s of 1. So s of 1, okay, 1 power 5 minus 1 is equals to 0. So does phi divides 0? Yeah, 0 by phi is 0, right? So phi divides 0. Okay, that is, I'll just have the, I have to take, assume s of k is true. See, I'll write here basic step, s of n is true, s of n I took, then I will write which is true, then what I will do. Now let us induction step. This induction step, we will assume s of n is true for all n is equals to k, for all n is equals to k, where k is greater than equal to 1. Okay, that is, now I will get k power 5 minus k, okay, is equals to 5m. Let me take, why? Because I have to take some is equals, I cannot write 5 simply big term, so I will simply write it in the form like this, k power 5 minus k is equals to 5m. Let us consider this as one equation itself. Now what I have to do, I have to find now, okay, I will tell it again properly, this time mistake won't happen. We will see, we will try once again. My theory is correct itself. Okay, so I have 5 power k minus k, okay, so k plus 1 k plus 1 power 5. Okay, yeah, let us just keep as it is. Since they asked here, sorry, they have given this divides by 5 or multiple of 5, this makes our problem very easier. Okay, here what I will do, so I have here I have to take k plus 1, right? So okay, like I wrote there, k plus 1 power 5 minus k plus 1. So I have for that k plus 1 power 5 minus k plus 1, which is equals to. So now what I will do, this k plus 1 is there, right? I will write in 3 ways. So k plus 1 to the power of 2 into k plus 1 to the power of 2 into k plus 1, then minus k plus 1. Now I have to open this square, k square plus 2k plus 1 into k square plus 2k plus 1 into k plus 1 minus k plus 1. I will multiply this two first, so it will be k square into k square plus 2k plus 1 plus 2k into k square plus 2k plus 1 plus 1 into k square plus 2k plus 1 into whole, this whole into k plus 1 minus k plus 1. Okay, now let me multiply. K square into k square is k power 4 plus 2k into k square is 2k cube plus k square plus 2k into k square 2k cube plus 2k into 2k 4k square plus 2k into 1 is 2k plus 1 into k square plus 2k plus 1. Now this whole thing into k plus 1. So first I will multiply this whole thing with k, then I will add again write this as it is as plus like that same term. So k into k, k power 5 plus 2k cube into k is 2k power 4 plus k cube plus 2k power 4 plus 4k cube plus 2k square plus k cube plus 2k square plus k. Simple, right? I am just multiplying this whole thing with k. So what will happen from that? Wherever k had the power, right, that only one power increase in all the k. So k was 4 here, k had the power 4 here, so it will become 5. 3 it had, it will become 4, same thing. Then plus all this number, because plus so once I will multiply with k and add, then add with multiplication of 1. Understand, like same how I did k square into this, then 2k plus into this plus 1 into this, same way 2k into this plus 1 into this. So I have to add again k power 4 plus 2k cube plus k square plus 2k cube plus 4k square plus 2k plus k square plus 2k plus 1. So now I'll add the k power 5. First I'll see where k power 5 is there. So k power 5 only one time. So k power 5 plus k power 4. Okay, I have here 2 plus 2, then here once I have 5. So I have 5k power 4. See, 2k power 4, 2k power 4, then k power 4 plus cube I will see 1 time 4 times. So 4 plus 1 is 5. Here 1 times 6. So 7, 8, 9, 10. So 10 k cube plus how many times squares are there? Let's see here 2 square, again here 2 square 4, then 5 here 1 time, then here 4 times, so it is 9 times, then here again 1 time, so again 10 k square plus how many times k is there? K 1 time, k here 2 times, so 1 plus 2 is 3 plus here 2 times plus 5k plus 1. Okay, then I have minus k plus 1. So if I remove bracket also, it won't impact anything. So here plus 1, here minus 1 will get cancelled. So now what I will do, k power 5 minus k I will group this term and this term I will group. Okay, then plus I will write off this 5 k power 4 plus 10 k cube plus 10 k square plus 5k. Now what I will do, I will take 5 common, k power 5 minus k plus, okay, now see here k power 5 minus k power 5 minus k is equals to 5m. So what I will do, I will just write 5m plus 5 common, k power 4, then 5 common, so 2 will come, plus 2k cube plus again 2k square plus only k. Okay, now I have 5m plus 5 into this. So now what I will do at the end, I will take again 5 common, so m plus same right of k power 4, 2k cube, 2k square plus k, and keep it as it. So now see here, after solving this completely, what I got something here. Don't worry what's there inside. Okay, you just have to get 5 into in the bracket something. Now you can say that given thing is the whatever we are getting the answer, it is a multiple of 5. Okay, so here we had written that n power 5 minus n is equals to 5 into some multiple positive integer. Here all are positive integers, right? M plus all these things are there. So even though this thing was minus, so m plus this is positive plus something, so it will remain positive. We know that. So we have this in the form of this. So multiplication of 5. So we can directly conclude that this is what this thing is equals to this, which is multiple of 5. Okay, and we can just prove it here. So therefore 5 divides k plus 1 whole power 5 minus k plus 1, s of k plus 1, right? That is s of k plus 1. Okay, it divides this, therefore prove. Okay, you understood, right? I just broke it down completely for you. Now let us go to fifth problem. This is the fifth problem of the day. So they have saying prove that if 4n is less than n square minus 7 for all positive integer n greater than or equal to 6. So from here few questions might start getting tricky or complex, but no problem, I will just explain you. Now given s of n is 4n less than n square minus 7, let me take an example. For all n is greater than or equal to 6, now I cannot take s of 1 here, that is foolish. So you have to take any value which is greater than or equal to 6. So let me take 6 as s of 6, because they have said n not greater than or equal to 1, and here n is greater than or equal to 6. So I will take from 6. So for 6 the 24 less than 30, n 6 6 the 36, 36 minus 1 is 29. Okay, I will write here 4 into 6 is equals to 24 less than 36 square minus 7 is equals to 29. Okay, 24 less than 29, it is true. So s of n is true. I will write the statement. Basic step done. I will go for inductive step. I should take s of n plus 1, right? So final answer also you can predict s of n plus 1. So okay, so first I have to take 4k, then here you can simply assume, right, 4k plus 1 should be less than k plus 1 the whole square minus 7. Okay, that should come. Just remember that, you know, right? Okay, I will just tell again. Every time your answer should be in the terms of s of k plus 1. You have 4k less than k square minus 7. So it should come, right? 4 into k plus 1 should be less than k plus 1 the whole square minus 7. Your final answer should be in this format. Okay. So now let me just start. So I can write s of k plus 1, s of k I have to take is such that 4k is less than k square minus 7. Now what I will do, s of k plus 1, okay, 4k plus 1 is equals to, so now s of k plus 1 is what, 4k plus 1 is equals to, now what I will do, I will add 4 on both the side. 4k plus 4 is less than k square minus 7 plus 4. Okay. See here we have n is greater than or equal to 6 here. If I just multiply 2 on both the sides, 2n is greater than or equal to 12. If I add 1 on both the sides, 2n plus 1 is greater than or equal to 13. Okay. Since 2n plus 1 is greater than or equal to 13, then it will be obviously be greater than 4. So what I will do, instead of this 4, I will write 2n plus 1. It should be greater than or equal to 4. I can say that. So what will become, 4k plus 4 less than k square minus 7 plus 2k plus 1. Since you are taking in terms of k, so this 2n plus 1 become 2k plus 1. Now what I will do, if I just open this, it is k square plus 2k minus 6. Okay, or you can simply just write minus 1 minus 7. You can write this like this. Okay, what I did, I just replaced this, I sent this minus 7 last and kept this thing inside. Now see here, it is k square plus 2k minus 1. It is in the form of k plus 1 the whole square. So I can write it as k plus 1 the whole square minus 7. And this, if I take 4 common, I will have k plus 1. Okay. So now you see here, like I said, what I had wanted was, okay, you can see here, right, if I keep it like this in the camera, yeah, it's perfectly visible. 4k plus 1 is less than k plus 1 whole square minus 7. Just do like this and remember, write the theory part, done. Okay. Fifth one, another. Okay, let me solve another sum, sixth sum. 2 power n greater than n square for all positive integer n greater than 4. Okay, n is greater than 4, so 4 is not included here. So 2 power n greater than n square s of n, such that n is greater than or equal to 5. So let me take 5 and verified s of 5 is 2 power 5 greater than 5 square. So 2 power 5, 2 to the 4, 4 to the 8, 8 to the 16. Okay, then 16, so 2 into 2 into 2 into 2 into 2 to the 4, 4 to the 8, 8 to the 16, 6 to the 36 greater than 25. It is true. So I will say S of n is true for all n greater than or equal to 5. Then I will go to induction step, where I will assume S of k is true where n is equals to k, for n is equals to k where k is greater than or equal to 5. Okay, S of k is true for n is equals to k where k is greater than or equal to 5. My k looks like x, but just adjust it. Okay, now what I will do, I have k power n greater than k square. Okay, so oh sorry, 2 power k it is, I will write again 2 power n, so 2 power k greater than k square. Now what I will do, I will multiply 2 on both the sides. So 2 into 2 power k is greater than 2 into k power k square, 2 into k square. Okay, now I have 2 into k square. So 2 k square I can write it as k square plus k square. So which is equals to k square plus, now see here, k into k, which is equals to k square plus, now see here, since k is greater than equal to, what to say, greater than 4, right. So what I will do, I will take 1 k as 4, 4 into k is 4 k, then k square plus 2 k plus 2 k. Okay, then I will simply write it as k square plus 2 k plus 1 again, to make it as k plus 1 the whole square. This thing perfect, you will be like, how this happened. Just remember this, because even in the textbook or any place they have not explained this properly. Till here I could say that because it is greater than 4, I am just taking 4 over there, 2k plus 2k. So 2k I am just making this as 1. How, God knows, but this is max, right. Even I don't know perfectly. Don't get bored like why he is not teaching properly or something, just like that you understand. So here 2 into 2 power k, it is nothing but 2 power 1 into 2 power k, 2 power k plus 1 greater than here k plus 1 the whole square. Now one thing let me say, so the given thing, just a second. So what was the given question? 2 power n greater than n square. So 2 power k greater than k square. I have to make it right in the form of k plus 1 terms. So 2 power k plus 1 greater than k plus 1 whole square. So my final answer would be like this, and I also got my final answer like this. Therefore I will simply say it off, it is true, and I will move on. Okay, then you have to write the theory part. Thus 2 power k plus 1 greater than k plus 1 for k greater than 4. This is precisely the statement S of k plus 1. Okay, then I will just do like that and finish off. Let me move on to the 7th sum, that is they are saying n factorial is greater than equal to 2 power n minus 1, or 2 power n minus 1 is less than equal to n factorial. They might give like this or like this, but you have to consider this. Just if they have given it in is also equal to, or you write like this and then assume, then you have to say S of n is this thing, then I will take S of 1 is equals to 2 power 1 minus 1 less than equal to 1 factorial, which is equals to 2 power 0 less than equal to 1, 2 power anything to the power of 0 is 1, 1 less than equal to 1, it is true. So I will assume S of k is also true for n equals to k, where k is what greater than equal to 1. Okay, so I will say true such that 2 power k minus 1 is less than k factorial. Okay, less than equal to, sorry, less than equal to k factorial. So now again what I will do here, I will multiply 2 on both the sides. 2 into 2 power k minus 1 is less than equal to 2 into k factorial. So again what I am doing here is, I should have this in the form of k plus 1. Okay, 2 into k is there. 2 into k, I have to write it in such a way that I have to get k plus 1, the only k plus 1 over here, k plus 1 the whole factorial. So how it is happening, what they have done here, they have simply directly taken, they have said that k plus 1 is greater than equal to 2. How? Because k is greater than equal to 1. If I add 1 on both the sides, k plus 1 is greater than equal to 2. So in place of 2, greater than equal to 2, so I will take least thing, so equal to 2. So what I will do, less than equal to k plus 1 into k factorial. Okay, this again what I will do, this thing I will consider as only, since less than equal to this was there, so instead of less than equal to, I will remove that and put only k plus 1 whole factorial. So 2 into 2 power 1 into 2 power k minus 1 is equals to 2 power k minus 1 plus 1, 2 power k. So I got it, 2 power k is equals to k plus 1 the whole factorial. Now if you see here again, given thing was n factorial, it is greater than equal to, what is the question, 2 power n minus 1. So I will just make k, n as k, n as k. So it should be in the form of k plus 1 factorial greater than equal to 2 power k plus 1 minus 1, which gives us only 2 power k. Okay, we got that answer. So we can say that again, if I do it in that such a way that I can simply write it as k plus 1 the whole factorial is greater than equal to 2 power k, and just finish it. See, beginning sum was very easy and understandable, but here when they give factorial or when they give divides some terms, or 2 into some 2 power terms, you have to do like this. In most the places what we did, in divide case, here right, the division, sorry, division was here. In this place we simply made it in such a way that I will get a multiple of 5 and add it off. Here wherever I had less than place, here I just added 4. In the question when 4n was there, I just added 4, and you saw here n greater than equal to 6, I multiplied by 2, 2n greater than equal to 12, added 1. So see here, greater than equal to 13. So it should also be greater than equal to, since it is greater than equal to 13, then obviously it is greater than equal to 4. So I will just consider, replace this 4 with the term, and even here I am multiplying by 2. See, for 2 power n into 2 n square I am multiplying by 2, for n factor also I am multiplying by 2. Okay, this thing done. Okay, so now let us see another question. They are saying for 8th question, I am just solving the sums here and explaining how it is done. So here they are saying n belongs to a positive integer, show that if n is greater than equal to 14, then n can be written as sum of 3's and or means sum of 8's. So I have to say 3 or 8, first 3's, then 8's, and both, like that. Okay, so I have to do like that. Then first I have to write S of n is equals to, n can be written as sum of 3's or sum of 8's is true for all integer n greater than equal to 14. So I will take sum of 14. Okay, so this can be written as sum of 3 or 8. So 14 is equals to like this. Okay. What is this? Okay. Okay. So from the given question, you have to consider it like that. So if I have to show you in a more precise way, just a moment. Let me open the textbook and remove that same thing and show you. Okay. Okay, in the textbook they have said any positive integer in the form of what is a sum of 5s and or sum of 7s. Okay, but here we have sum of 8s, so here 8 plus 8 should come. Okay. Okay, so now let us see sum. Okay, I have to write in either way. Okay, n can be written as sum of this thing or sum of this thing, and like that. So 14 can be written as 3 plus 3 is 6, 3 plus 3 is 6, and 6 plus 8. Okay, that is what to say, 14 is right. 8 plus 6 is 14. Okay, such a in same way for k, n greater than or equal to 14, we have to write like that. So if I have to check with 15, can I add? So 8 plus 6 is 14, so I have to add 7. 8 plus 8 is 16 directly. Oh, I can simply take what to say, sum of 3 and 4, right? So I can simply say 5 times 3, 3 plus or 8 plus 3 is 12 plus 3, that is 16. 11, 14, sorry. So I can take 3 5 times. Okay, again it is sum of 3's or sum of 8's, right? So if if they say 16, I can write 8 plus 8. If they say 17, I can write as 8 2's are 8 plus 3 plus 3 is 14, then 14 plus 3 is 17. You understood, right, how what the question means. So n can be written as either 3 plus 3 or 8 plus 8, or only 3 plus 3 plus 3, or only 8 plus 8 plus 8, like that, so on, like that. Okay, that is a given question. So if I take s of 14, so using only 3 and 8, I have to make a sum which will be equivalent to 14. You understood, right? So then s of n is true for all, like that you will write. You will go for induction step. In induction step, what you will do, k is equals to something. So it will be 3 plus 3 so on, plus 8 plus 8 plus 8 so on. Here and also 8 will be there, n won't come. Okay, don't get confused. So n number of times 3 is there. Okay, now suppose the representation of k has r numbers of 3's and s numbers of 8. What they are saying here, what is saying, how many times 3 are there? They are saying r number of times. How many times s 8 are there? S number of times. Okay, and k is greater than or equal to 14. Okay, so since k is greater than or equal to 14, here see, k is greater than or equal to, so how we got this? Not this, this one. Okay, since k is greater than or equal to 14, so r should be greater than or equal to 2 for sure, and s should be greater than or equal to 1. How we got this r greater than 2 and s greater than or equal to 1 is from here. Here r, suppose 3 we are relating with r, right? So 2 times 3 had come. So number of times 3's are there in cage are r. We have said that let r be the number of times the sum of 3's, and s be the number of times the sum of 8's. So here for 14, for greater than or equal to 14, least term, least was 14. So least how many times r was used? 2 times were used. And least how many times 8 was used? S one times it was used. Like that we will tell. But though here you can see for 17, see even for 17, 1 time 3 is not used, more than 1 time 3 is used, and 8 is always used, but only 1 time, minimum 1 time, but r is used minimum 2 times. see here 2 times, here r is not used at all, okay, but still you can use r here for 16, just leave that. R is not used, then we won't be using r times, only s sum will come. I am just explaining in general how the sum can be written. So, okay, now what I will do, therefore k plus 1 can be written as, okay, sum of what to say, this plus this plus 1. So, how I can say that, so 3 plus 3 plus 3 so on, plus 8 plus 8 plus 8 so on, plus 1. Now, what I will do, this thing is r, this thing is s. So, I will take remove one s from this bracket. So, it will be like this will be same, plus here s minus 1 will be there, here 8 plus 1 will come, okay, 8 plus 1, which is equals to, this thing can be written as, see, r plus s minus 1 plus 9, 9 can be written as 9, right. So, 3 plus 3 plus 3. So, now here it will be r plus 3 plus s minus 1, okay. So, now okay, r plus 3 and s minus 1. So, here k plus 1, okay. So, k plus 1, so if you take 15, okay, k plus 1 is 15, how you will write 15? So, 15 can be written as, s will, here r is already, r is greater than equal to 2, right. So, r is already occurred 2 times, but s is becoming minus, s is here minus 1. So, wait, I will just explain here what has happened. Let me use this board itself to explain properly. We know that for k, if you are taking k as 14, okay, if I am taking k as 14, then how many times 3 is, r is there, 3 is 2 times and s is 1 time. If I take k as 15, oh, I took the wrong pen, okay, if I take k as 15, then 5 times 3 I am using, I said you right, okay, 1 2 3 4, 5 times 3 is there. So, to prove that this is for n, okay, this is n plus 1, right. So, to prove that, here what I am saying, here r is greater than equal to 2 and here I am saying s is greater than equal to 1, but here what has happened. So, I will just first let me write this, r greater than equal to 2, then here r greater than equal to 2 plus 3 are coming, and here s, what s has happened, s has become minus 1. So, here basically this things I am saying as r number of times, okay, this is r number of times, here number of times is s, here what is happening, number of times. So, r plus 3 is happening, and here how many times s has come, s has come 1 less time than previous. So, you can simply say that here k plus 1, right. So, k plus 1 should be in such a way that r should be plus 3 and s should be minus 1. How to achieve this, that I have to write here. So, what I did, basically I wrote k is equals to 3 plus so on 3, 8 plus 8 plus so on plus 8. So, what I did, I had to do this minus 1 for s, okay, s should be minus 1. So, what I did, I removed 8 outside. So, 8 plus 1 I wrote as 9, 9 can be written as 3 plus 3 plus 3, okay. So, this is nothing but r plus 3. So, already r times r was there, then here 3 extra times 3 has come. So, number of 3's usually which will be there is r, but additionally 3 times 3 is coming. So, r plus 3, here s minus 1. I hope you understood the question what is saying. Once again I will just read out. So, here what is happening, they said that show that for all n greater than n belongs to positive integer. So, n should be sum of 3's or and sum of 8, which means a given number n, let me just write here, a given number n where n is greater than equal to 14 should be sum of either 3 plus 3 plus 3, or so it can be only sum of 3's, or it can only be sum of 8's, okay, according to the question, so on, or it can be sum of 3's or 8 and 8, sorry, 3's, sum of 3's or sum of 8's or sum of 3's and 8's. I am saying 8's, t sound is coming, 8's, okay, don't go that what am I saying something, okay. Now since n is greater than equal to 14, so I will assume s of 14. So how can I write 14 in terms of only 3 and 8? So it is 3 plus 3 plus 8, understood, right? So how many times 3 is there? 2 times. How many times s is there? 1 time. So what I am saying, in this given s of k, so okay, I got this. First I will say s of n is true, blah blah blah, so on. For s of k, what I am doing, s of k I am assuming like this. So where r denotes the number of times 3 is used and s denotes the number of times 8 is used, okay. So from this given equation you can say that for r s of k equals to 14, r is greater than equal to 2 and s is greater than equal to 1, okay. Now I will just erase this part. Now what I am doing, s of k plus 1 I have to take, s of k plus 1. Since we have already took s of k is equals to 1, I will just add k plus 1 here. So a plus 1 was 14, k was 14 first, so k plus 1 will become s of 15. Don't write s of 15, but just solve s of 15. So how you will do s of 15? You cannot take 8. If you take 8, so 8 plus 8 is 16. So I cannot take again 1 8. So what I will do, 8 plus 3, that is 11, again 8 plus 3, that is 14, again 3. So this is going 17. So I won't consider 8 itself. So what I will do, I will add 3 5 times, okay. Now you see here, what is r, that is 5 times, and how many times s, that is 0, okay. In better way I will say how r has changed. R was greater than equal to 2, okay, r was there and s was there. S is number times 8. How many number of times 8 was there? S was 1, okay. Now what has become, s has decreased, s is reduced 1 time and r has increased 3 times. You can see r was only this much, but here number of times 3 has come, and 8 s was reduced 1. So you have r plus 3 into s minus 1. So your final answer is also the same way, k plus 1 is equals to r plus 3 plus s minus 1, okay. It was very simple actually, much was not required, okay. Same way we also have another question here. So many questions are there actually on the mathematical induction. So they are saying, by mathematical induction prove that for every integer n, for all n, number of a n is equals to 5 power n plus 2 into 3 power n minus 1 plus 1. It is a multiple of 8, which is equals to 8 into some positive integer m. So they are saying it is a multiple of 8. We can simply write it as into 8 like that something, okay. So first I will take for all n, right. So I will take s of this, let s of n be such that this thing I will write, then s of 1 I will take a1 such that a1 is equals to 5 power 1 plus 2 into 3 power 0 plus 1 is equals to 8, okay. 5 power 1 is 5 plus 3 power 0 is 1, 2 into 1 is 2 plus 2, sorry, plus 1, this one is equals to 8, correct. 5 plus 2, 7 plus 1, 8 is equals to 8, proved. So we will say s of n is true for all positive integer n, and so let us assume s of k is also true for n is equal, k is equals to n, where k belongs to positive integer, or k is simply you can say greater than equal to 1, okay. So that is s of k if I take, such that a of k is equals to 5 power k plus 2 into 3 power k minus 1 plus 1 is equals to, okay, I will just write it as it is, a multiple of 8 I am saying, right, multiple of 8, keep it as it is, just keep it here. So, now what I have to take, we have to find k plus 1, okay. So, what I will do, I will to get k plus, so here I have a of k, so I will make it as a of k plus 1 minus a of k. Instead of going towards the right, what I am doing, I am just subtracting it one term behind. So, I am taking it in the form of this. So, what I will do, this same thing I will write first, okay, 5k plus 2 into 3k minus 1 plus 1 as it is, okay, here minus, wherever k is there I will make it as k plus 1, okay, wait, plus 1, then here 2 into 3 power k plus 1 minus 1 is only k, then 5 k plus 1, okay. Usually here we are, instead of adding, we are just subtracting it, okay, we are just subtracting minus of k plus 1, okay, a of k plus 1, sorry, a of k plus 1, but instead of, we don't want this a of k plus 1 as minus, so I am multiplying again minus, okay, understood, right. So, then I multiplied with negative sign. So, what will become? So, it was a of k minus a of k plus 1. So, if I multiply with minus, so it will become, this will be minus, this will be plus, and then I rearrange a of k plus 1 minus a of k. You understood, right? Like this, I will just write like this, and then what I will do, I will multiply. Okay. So, this will be 5 power k plus 1 plus 2 into 3, 5 power k, okay, then this plus 1 minus 5 power k plus 2 into this, okay, 2 into 3 k minus 1 plus 1. So, this thing here what I will do, I will just open up the, what to say, so this will become minus, or even this will become minus, and even this will become minus, because this was in bracket, right. If I open the bracket, this will be minus times, and here I have this thing. So, now what I will do, I will multiply here again, I will open up, okay, or better let me just rearrange or group the terms. So, first I will group these terms, okay. So, I will take 5 power k plus 1 plus 1 minus 5 power k plus 1, okay. Then I have plus 2 into 3 power k minus 2 into 3 power k minus 1. So, from this I can group 5 power, so see 5 power k plus 1, right. So, I can write 5 power k into 5 power 1. So, if I multiply 5 power k plus 1, okay, then minus 5 power k, plus 1 minus 1 cancel, plus 2 I am taking common, 3 power k minus 3 power k minus 1, okay. This comes like this, 5 power k into, now here what I will do, 5 I will take common, 5 power k I will take common, here also 5 power k, here also 5 power k. So, 5 power k I will take common, so it will be 5 minus 1 plus, and here what I am doing, I am taking 2 power 3 2 into 3 k minus 1 common, I will take 2 into 3 power k minus 1 if I take common. So, if I multiply this again inside, I have to get these two terms. So, how it will be, 3 minus 1, okay. or basically you can simply say that I took this term again outside. If I take outside, then only this inside two things will be remaining anyways. Understood, right? Much more, nothing else has happened here. Then I will have 5 minus 1 is 4. 4 into 5 power k plus here 2 into 3 power k minus 1 into 3 minus 1, that is nothing but 2. This will become 2 again. So, I will have 4 into 3 power k minus 1. Here again you can take 4 common, 4 into 5 power k plus 3 power k minus 1. Okay. Then now here say 5 and 3 are odd, which implies 5 power k and 3 power k minus 1 are also odd. Okay. We are just saying that 5 plus 3 gives us the odd number. So, we are assuming that 5 power k plus 3 power k minus 1 will also give us an odd number. Therefore, I will write it here again, 4 into 5 power k plus 3 power k minus 1 is a multiple of 8. Okay. I am just setting how 8 comes is, so you know that odd number is 2n minus 1, right. So, here 4 into 2n minus 1, so I am taking 2 outside. So, 8 into n minus 1, so it will be 8 into k minus 1, like that. Understood, right? How I got 8? It is a multiple of 8. Since it is odd, so odd number, how odd numbers are written as 2n minus 1, like that. You can just write 8n, it is a multiple of 8. Simply write that is blah blah, everything you have to write and prove. And then one of the interesting and mostly asked questions on another we have, prove that by matching the 6 power n plus 2 plus 7 power 2n plus 1, it is divisible by what is this, 43. Okay, for which, for each, for all n belongs to z plus, for all positive integer n. Instead of writing that big theory, I wrote this much. So, first I will say let a n is equals to 6 power n plus 2 plus 7 to the power of 2 n plus 1. Then basic step, I will take an a as 1. So, see here usually we are taking s of 1 and all. So, till where it was, till here itself, right, till this step, but here also we are taking a power that and all. So, from here which you are doing is a different kind of mathematical inductions. I do not know the name, but the two were there, right. One was in the beginning I said order of something principal, and another it was something which was in that syllabus copy. Let us forget. So, we will take a of 1. So, 6 power 1 plus 2 is 3, 6 cube plus 7 power 2, and 2 into 1 is 2 plus 1 is 3. So, 6 power 3 plus 7 power 3, which is equals to 559. So, if I divide 559 by 43, so I think I will get 10, 11, 12, 13. I think 13 times of this 43 ones are, and divide 33 times. How I am doing? Because see 3 is there here, right. So, 3 tens are, it will give 0 here, and again 3 3 is 10 I have, plus 3 3 are 9, right. So, 9 should be the last. So, 13. You just see it will be 559 by 43 is 13 itself. Okay. Now, it is true. So, we will say that a of k is true for all n is equals to k, where k is greater than or equal to 1, like that. Then again what I have to take, therefore, a of k plus 1 is equals to 6 to the power of k plus 1 plus 2 plus 7 to the power of 2 into k plus 1 plus 1, which is equals to 6 to the power of k plus 3 plus 7 to the power of 2k plus 3. Okay, I will get like this. Then what I will do? Here I have 6 to the power of k plus 3, right. So, I can write it as 6 into 6 to the power of k plus 2. This is 6 to the power of 1. If I multiply this, I will get k plus 3 itself, plus 7 square into 7 to the power of, sorry, here it should be 2k plus 3. I wrote only 2 plus 3. Okay, 7 to the power of 2k plus 1. If I multiply this now, I will get 2k plus 1 plus 2, that is 2k plus 3. Okay. Now I will write it as 6 into 1 as it is, then 6 power k plus 2 as it is, plus 7 sevens are 49, 7 to the power of 2k plus 1. Okay. I will write 49 as, I will write 49 here. Now what I have to do, since they have asked me that it is divided by 43, so what I will do, I will write 49 in terms of 43 plus some term, which will give me the sum of 49 k plus 2 plus 43 plus 6 into 7 power 2 k plus 1, which is equals to 6 into 6 to the power of k plus 2 plus 43 into 7 power 2 k plus 1 plus 6 into 7 power 2 k plus 1. Okay. I am just open the bracket, so I have to multiply this with this once and this with this once. Okay. Then now again in this term and this term I can take 6 as common. If I take 6 as common, I will have 6 power k plus 2 plus 7 power 2 k plus 1. Okay, this is in the form of this is see a of k. Here a of k will have 6 power k plus 2 plus 7 power 2 k plus 1. Okay. So I will write this then plus remaining I will write off. Okay, 43 into 7 2 power k plus 1. So I will write 6 into a of k plus 43 into 7 to the power of 2 k plus 1. I will write it as it is. Okay, we know that 43 ak is divisible by 43. So I can simply say that this is equals to 43 into some integer, right, m. So instead of 6k I can write 6 into 43m plus 43 into 7 power 2k plus 1. So I can take only 43 common. So I will have 6m plus 7 to the power of 2k plus 1. So I have this thing as a multiple of 43. Therefore I can simply say that a of k plus 1 is a multiple of 43, or it divides 43 divides a of k plus 1 terms and all. Understood? It was very simple, right? Much was not there. So I have solved this 10 questions. There are few other questions where we will be taking summations and by okay, let me just check. Okay, so I have still many problems are left on this same basis, where we sometimes we will be taking h is equals to 1. Yeah, so I guess some 1 2 3 4 5 some 7 problems are there. Okay, let me just complete all of the mathematical induction problems now itself. Okay. Okay, so I just checked, we don't have much problems left on mathematical induction, just a few more problems are left, and then we'll be done with this mathematical induction for good. So yeah, most of all the problems are there, right? You just hold and see which place which problem I am doing. So here one question is prove that for I is equals to 1 to n, in summation of like 1 to n. Okay, so 1 divided by I into I plus 1 is equals to n divided by n plus 1 for all n belongs to z. Okay, summation of I equals to 1 to n. So here this place n will come, here also n can come. So 1 divided by n into n plus 1, like that it is, so on so many terms. This is equal to, like this they are saying. So solution, first I have to say S of n. What is S of n? Can be written as the given statement. Okay, given statement. So then what I have to take? Shit, S of 1 I have to take. S of 1 is 1 divided by 1 into 1 plus 1 should be equal to I, right? So even I n both are same, then I have 1 divided by 1 plus 1. So 1 divided by 1 plus 1 is 2. So it is nothing but 1 by 2 is equals to 1 by 2. Both are same. So S of n is true for therefore we can assume S of k is also true. So first we will write S of n is true for all n greater than equal to 1. Then I will say S of k is also true for all for n is equals to k, where k is greater than or equal to 1, like that. Now I have to take assume like, so I have to write. So how I will write? So I will just write 1 divided by 1 into 2 plus 1 divided by 2 into 3, so on, plus 1 divided by, I will write like this. Okay, first I will write like this, k I will put k into k plus 1, okay, which is equals to, same way I am just writing what to say, k I am writing n into n divided by n plus 1, so I will write k divided by k plus 1. This is my, this is true, I will assume. Now what I have to do? I have to now just see here, this is the last term, right? Like I said, wherever this kind of problems are being asked. So what was the last term? That was 1 divided by k into k plus 1. So I have to write this k plus 1 in the form of plus 1 type. So in k plus 1 terms, so k will become k plus 1. Then again k plus 1 plus 1 is there. So here I will just open up. If I open it up, so how it will be? K plus 1 plus 1, k plus 2. I am getting this. So I will multiply. So I will add this on the both sides. Okay. So here same thing, plus, first write like this, plus 1 by k into k plus 1, again 1 by k plus 1 into k plus 2 is equals to k divided by k plus 1 plus 1 divided by k plus 1 into k plus 2, okay, k plus 1 into k plus 2. Again now see here which thing I can take as a common. Just a second, I will connect the charger for the okay. So now in this thing k plus 1 is common, k plus 1, but I will take, I cannot take k here. If I take here, then in the denominator I have to multiply k, but let us not do that. What I will do, I will just take 1 by k plus 1 common, okay. If I take 1 by k plus 1 common, what is remaining? K plus 1 divided by k plus 2. Now I have to solve this inside part. So first I will do just cross multiplication. So what we will get? 1 by k plus 1. So cross multiplication, k into k plus 2. K into k is k square plus 2k plus 1 divided by k plus 2. So this thing can be written as k plus 1 the whole square, you know. So I will have now 1 divided by k plus 1 into this thing, k plus 1 the whole square divided by k plus 2. Okay, now what I can do, I can just here I have, okay, either I can cancel this out and write it as k plus 1 divided by k plus 2. Okay, so now it will cancel out. See, I have k plus 1 here in multiplication, right, 1 times this square. So what is remaining? K plus 1 divided by k plus 2. Now see here in the question what they had given, it should be equal to n divided by n plus 1, that is nothing but k divided by k plus 1. If I write this in terms of k plus 1, so in the numerator it should be k plus 1, in the denominator it should be k plus 2. So finally I got my perfect answer, k plus 1 divided by k plus 2. You have to write that theory part, this is in the form statement like what to say, s of k plus 1 and s of k plus 1 also true, blah blah blah, all the theory part you have to write. Then here again another question, they have said establish the following using mathematical induction. So summation of I is equals to 1 to n, same, I into 2 power I is equals to 2 plus n minus 1 into 2 power n plus 1. Okay, 2 power n plus 1 times of n minus 1 plus 2, like that. So first I will say let s of n be the given statement. I have to take s of 1 is equals to 1 into 2 power 1 is equals to 2 plus 1 minus 1. 1 minus 1 is 0, so I won't write anything, that will become 0. So only 2 is remaining. 1 into 2, 2 equals to 2. Same. So I will write S of n is true for all n greater than or equal to 1. Therefore, we assume, this is the basic step in induction step, I say we assume S of k is also true for n is equal to k, where k is greater than or equal to 1, and I will write S of k such that, then what will come, 1 into 2 power 1 plus 2 into 2 power 2 plus so on into here k into 2 power k is equals to 2 plus k minus 1 into 2 power k plus 1. So, okay, now what do I have in my right hand side? 2 plus 2 plus k minus 1 into 2 to the power of k plus 1. If I write in the terms of k plus 1, so here k will become k plus 1, and here I have minus 1, so this will be only k, and here I should have k plus 1 plus 1, it will become k plus 2. So, 2 plus k into 2 to the power of k plus 2, this should be my final answer. Okay, according to my how I have understood these questions, that should be my final answer. Okay, so let me start now. So I wrote as it is like this, so on 2 power k. So now what I will do, I have k into 2 power k, right? So how, what terms I have to add? So last term is k into 2 power k. Now I will make it as k plus 1, k plus 1 into 2 power k plus 1. So this is the term which I have to add on both the sides. So I will write same thing, k into 2 power k plus k plus 1 into 2 power k plus 1, it should be equal to 2 plus k minus 1 into 2 power k plus 1 plus k plus 1 into 2 power k plus 1. Okay, I have to add k plus 1 into 2 power k plus 1 on both the sides. That's what I have written here. Now this thing we have to simplify. So I have 2 plus k minus 1 into 2. So here I have 2 power k. Okay, let me just write 2 plus 2 power k I have common, 2 power k plus 1 common. So what will come, k minus 1 plus k plus 1, minus 1 plus 1 cancels, so only 2 k remains, 2 plus 2 power k plus 1 into 2 k. Now see here, I can write it as 2 plus k into 2 into, I am just writing like this, into 2 power k plus 1. Now I will take only these two terms. So 2 plus k into, this is 2 power 1, 2 power k plus 1 plus 1, that is k plus 2. Like I said, 2 plus k into 2 power k plus 2, same thing I got. Very simple. I see it has become so simple. From the question, by seeing, you will be like, oh my god, summation is there. By seeing itself, it's like hectic kind of thing, but we just solved it in a very simple manner. Nothing much was there. Okay, we have another question. If you have any doubt in one of the question, just what to say, write it down in the comment or something. I will try to solve that. Anyways, you guys won't do that. Still, h1 is equals to 1. They have given, let h1 is equals to 1, h2 is equals to 1 plus 1 by 2, h3 is equals to 1 plus 1 by 2 plus 1 by 3, so on. hn is equals to 1 plus 1 by 2 plus 1 by 3 plus so on 1 by n. Okay, then what they have said, prove that pt summation I is equals to 1 to n h of I is equals to n plus 1 into hn minus n for all n greater than or equal to 1. Okay, so we will say S of n is a given statement, then I will take S of 1. S of 1 means what, h1 is equals to 1 plus 1 into h1 minus h1 minus 1. Okay, this is equals to h1 is what, 1 is equals to 1 plus 1 is 2 into h1 is what, again 1 minus 1, sorry, okay, 2 into 1 minus 1, it is like this. Sorry, my bad. So it is equals to 1, so 1 is equals to 1, s of 1 is true for all. Okay, I will just write again. See, h1 is equals to n plus 1 into h1 minus 1. h1 is 1 is equals to n plus 1 is 1 plus 1 is 2 into h1 is 1 minus 1, which is again 2 minus 1 is equals to 1, 1 is equals to 1 over hn. We got of hn is true, we will say. Then in induction step, in induction step s of k is also true, we say, for n is equals to k for all k where k is greater than or equal to 1, like that. Then we have to what to do. Okay, so see here, so on, if I add here, we know that hk, so I should take s of h of k, right. So you know that last term was 1 by n, so it should be 1 by k. So in terms of k plus 1, it will be 1 by k plus 1. So I think we will be adding h of k plus 1 on both the side. Okay, you got to know now how to add on both the side, that thing. Now h of k, they said here, where is the tissue paper? Okay, it's here. We got to know 1 by k plus 1, we have to add 1. What is 1 by k plus 1? But h of k plus 1, right? Simple. Now we have it is equals to h of what they gave. Where is the question? From the question, yeah, k plus 1 into h of k minus k. So I have to write in the form of k plus 1 term. So it will be k plus 2 into h of k plus 1 minus k plus 1. Okay, this, in this way I have to get the answer. So I will write off s such that, like that, so on. Here it will be 1 plus 1 into 1 by 2 plus 1 by 3 plus so on 1 by k, or else I can just write h1 plus h2 plus so on hn plus, sorry, hk plus hk plus 1 is equals to k plus 1 into hk minus k. So what I will do, hk, right? Oh, sorry, here k plus 1 won't come. So now what I will do, add h of k plus 1 on both the sides. So hk plus h of k plus 1 is equals to k plus 1 into h of k minus k plus h of k plus 1. h of k plus 1 is nothing but 1 divided by k plus 1. Okay. So here what I can take common. So what I am doing, I will take k plus 1 common. How that k plus 1 common will come? Wait, I will just tell you. Before writing any common, so here what I will do, this one term is here, right, h of k. So now see here, for h of k plus 1, okay, see here we have here 1 plus, okay, let me just write some, okay, I will write here and show you. Okay, so I have 1 plus 1 by 2 plus 1 by 3 plus 1, okay, so on 1 by n plus 1 by, okay, let me write in terms of k, 1 by k plus 1 by 1 k plus 1, k plus 1. Now see here, till here it is h of k, right? We know that, right, h of k, because so on, like h of k plus 1 by k plus 1. That's what they are doing. What they did in from the textbook, k plus 1 they wrote off into h of k plus, okay, h of k, sorry, till again plus 1 you are taking. So that is h of k, wait, h of k plus 1 by k plus 1. It is nothing but h of k plus 1. Okay, so what I am doing, instead of h of k I am writing h of, so h of k plus 1 is equals to this thing. So I can just write that h of k is equals to h of k plus 1 minus 1 by k plus 1. I'll okay is equals to h of k plus 1. Okay, see here. I can simply say that h of k is equals to k plus 1 is equals to 1 plus 2 1 by 2 plus 1 by 3 so on up to 1 by k plus 1 by k plus 1. So here this much is 1 by h of k plus 1 by k. H of k plus 1 by k is equals to h of k plus 1. So now what is happening here? I am sending 1 by k plus 1 that side. So h of k is equals to h of k plus 1 minus 1 by k. So h of k plus 1 minus 1 by k plus 1. Instead of h of k I wrote like that, then minus k plus h of k plus 1. Okay. Now what I can do, now I can start taking this common term. So which I can take as common, that is nothing but h of k plus 1, or you can take only k plus 1 also, k plus 1 into h of k. Okay. Let me just continue from here. So I can write it as k plus 1 into h of k plus 1 minus, here only 1 will come. Why? Because I am taking this 2 as this as common. So 1 by k plus 1. So here k plus 1 went out, right? So here 1 will come. Just a minute. Then minus k plus, what is this, h of k plus 1. Oh, my voice, sorry for that. I did not see that that earphone had went down. Okay. So here k plus 1 into h of k plus 1 minus 1 minus k plus h of k plus 1. So here what has happened? So sorry, here this was there and here this was there. So I just multiplied it. Okay. Sorry, I said I took common. If you multiply this, you will have k plus 1 into h of k plus 1 minus k plus 1 into 1 by k plus 1, that is, this is cancelled. So only this remains. Okay, once multiply with this, once multiply with this, here it will get cancelled, minus 1 only will remain. So that minus 1 came here, multiplication like that happened. Okay, you understood, right? Now you have k plus 1 into h of k plus 1, then here minus 1 minus k plus h of k plus 1. So if you take now what you can do here, k plus 1 plus 1, okay, into h of k plus 1 minus k plus 1. Okay. So what I just did, I took this as common. Okay, let me just write it properly here. So I will write h of k plus 1. Okay, if I take this common, so what is the meaning? K plus 1 into 1. Okay, into 1 minus 1 minus k plus 1. So I will write it as h of k plus 1 into k plus 1, again plus 1, this one I am taking inside grouping, and then minus 1 minus k, then again h of k plus 1 k plus 2 minus of 1 plus k. Same thing will happen here, k plus 2 into h of k plus 1 minus k plus 1. Okay, when I said you in the beginning, I want the answer in the form of like this. So just compare, you got it. Okay, it was very simple, right? Much was not there. Okay, you understood. So I think this much part was only for mathematical induction. I tried to like answer all the questions for which comes under mathematical induction. If you have any doubt, just message in the comments. I'll also make a video on only a model question paper once, so that you will be having idea of the proper answers, how to solve. You will always be, obviously you will be having the answers, right? But how to get that answers, I'll just explain that once I am completed with all the 5 modules. Thank you. And if you are kind enough, then if you just don't mind, just give a like and subscribe my Though the video is ending, you guys are so selfish. I don't understand. Every time before the exam you watch, how many members watch? Okay, almost 50-60 members, I don't know, but according to the views, uh, according to the subscribers, so views will be repeated but subscribers won't be repeated, right? 30% only like, okay, 30% not only like, 30% has only subscribed. Remaining 60% of the people has not even subscribed the channel. Okay, I do this a lot, man. See, I can just finish the studies. How much time I took to like write here, solve and explain. Within that much time I could have completed one whole module by myself. So I'm just trying to help you guys. So even you should help me by like subscribing and liking, right? Anyways, I'm not forcing, I'm just saying, like, keeping my point of view. So it's good if you do it. Okay, just do it. What's there in that? Just do it, man.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.